Hello from the Massachusetts Institute of Technology, and welcome back to Today I Learned Climate. I'm Laur Hesse-Fisher. Today we're taking on a question from Jose R. of Cuernavaca, Mexico. Jose asks, don't plants do better when there's more CO2? Which is a really astute question, because if you know only 3 facts about carbon dioxide, I bet it's these. First, we breathe out CO2 when we breathe in oxygen. Second, plants do the opposite. They take in CO2 and produce oxygen. And third, carbon dioxide is the most important climate pollutant that is currently warming our planet. Today's atmosphere has about 50% more CO2 than it did before we started burning massive amounts of fossil fuels. But is this great news for plants? We asked this question to Professor Des Marais, who studies the interactions of plants and their environments at the MIT Department of Civil and Environmental Engineering.
The short answer is that most plants will grow faster and bigger with extra atmospheric CO2, all else being equal. So if you have plenty of water and plenty of nutrients, plenty of space, then that does seem to hold true.
With more CO2 in the air, plants can create more energy and plant tissue. And not only does this logically make sense, scientists have seen it happen in their experiments. But that's not the whole story. Because the more that we make these experiments look like the real world, the less that plants actually benefit from the extra CO2. So to get the full picture, it's helpful to understand the 2 main ways that scientists test how plants grow when there's more CO2 around. First, there are what's called chamber experiments. These happen in enclosed areas, like a laboratory or a greenhouse, where scientists pipe in extra CO2. The other way to do this is in an open environment, like on a farm outside. Here, scientists install a lot of pipes in a ring to pump in CO2-enriched air onto a field. And there are CO2 sensors that control the pumps in order to maintain a certain level of CO2 on that field. Now, both types of experiments have shown that CO2 speeds up plant growth. It's what scientists call the CO2 fertilization effect. But where it starts to get a little wrinkly is when we look at the differences between these 2 experiments.
Chamber experiments vastly overpredict the CO2 fertilization effect. So if you grow a plant in a chamber where things are well fertilized and the humidity is controlled, there's plenty of water, then yes, most plants will grow bigger and faster. But that effect is much more pronounced in growth chambers than it is in the field environment.
Yeah, this tells us something crucial. In the real world, plant growth responds to way more than just how much CO2 is in the air. And the more open field experiments that scientists do, the more complicated the picture gets. Some crops, like wheat and potatoes, seem to love extra CO2, but others, like corn, hardly respond at all. A lot of forest trees grow faster with extra CO2, but they seem to respond most as seedlings, and then less after they get larger. An experiment in a desert ecosystem found that plants there only liked extra CO2 in wet years. And some plants see extra growth for a while and then level off, possibly because they hit the limits of some other nutrient like nitrogen or phosphorus.
So there are some systems that are nutrient limited, and you do not see the CO2 fertilization effect. It just doesn't happen.
If there's any simple takeaway here, it's that the extra CO2 in our atmosphere is not going to affect all plants in all places the same way. Even though a lot of plants do grow faster with more CO2, it doesn't mean that every farm and forest is going to benefit. But maybe, Jose, what you're really trying to get at is, will plant life on average do better in a high CO2 world? Here are the things to consider when answering that question. First, scientists have documented that the amount of CO2 absorbed by plants has been rising worldwide since the 1960s. So that points to enhanced plant growth so far, yeah. But we can also look to the past to help answer this question. Scientists have found ancient soils trapped in rocks and measured the carbon inside of them. And that's how we can learn about ancient climates that were quite different from our own.
There have been times in Earth's history when CO2 was much, much higher in the atmosphere than it is now. So if you go back far enough, and I mean like far enough more than 360 million years ago, atmospheric carbon dioxide was over 2,000 parts per million. That's about 5 times what it is today.
And by all available evidence, that was a pretty great time for plant life.
In fact, this is what led to much of the carbon that we're now digging up. All of that CO2 got sucked out of the atmosphere by these huge forests, and as that got buried, it turned into coal, which we're now burning. This period, however, was extremely warm. This is not a time that you and I would ever want to visit. This is like mean global temperatures around 30 degrees Celsius. That's way over 80 degrees Fahrenheit. So imagine it being summer all the time, all over Earth. And then the other thing we should say is that the pace of change in the past, a couple hundred million years ago, was much, much slower. Historically, these changes would have happened over tens of thousands, if not millions of years. Whereas we've increased carbon dioxide in the atmosphere by like 50% over just the past 150 years.
And this is where we can tie in with what we talked about in the first part of the episode. Plants in general can do well in a world with much more CO2. But will the plant species that we actually have today be able to cope with the exceptionally fast climate change that we're experiencing? Today, climate change is already deepening droughts in places like the American West. And those droughts reduce the water supply for plants while also increasing the risk of wildfires. In other places, climate change brings the complete opposite problem: flooding from excess rain or exposure to salt water from rising seas. And pests that enjoy warmer winters are on the rise in much of the world. And in extreme heat waves, plants can be injured or destroyed. So for many plants in many environments, these changes are likely to be at least as important as how much CO2 is in the air. So, Jose, can plants grow faster with more CO2? Absolutely, under the right conditions. But in the real world, that CO2 is driving changes that make things less stable for humans and for plants. And we don't know whether the plants that we rely on the most today for food and for our natural ecosystems will come out ahead. So we hope we answered your question today, Jose. To all of our listeners, do you have a question about climate change? Then ask us. Visit climate.mit.edu/ask or leave us a voicemail message at 617-253-3566. We'll be releasing answers as episodes here on TIL Climate, as well as at climate.mit.edu. And we would love to hear from you. Send us a message at climate@mit.edu and let us know what you're working on and who you are and why you listen to the show. Today I Learned Climate is a climate change podcast of the Massachusetts Institute of Technology. Aaron Krol is our writer and producer. David Lishansky is our sound editor and producer. Michelle Harris is our fact checker. Sylvia Scharf is our climate education specialist. The music is by Blue Dot Sessions, and I'm your host and executive producer, Laur Hesse Fisher. A big thanks to Professor David Des Marais for speaking with us, to Andrew Moseman, who did the original reporting for this episode, to Jose R., and to all of you, our listeners, for your climate curiosity.